Hi everyone, hope you're doing well. This is a video to go over the August 2019 Algebra Regents. Okay, make sure that you post all of these pages on Google Classroom so you get credit for it. And hopefully this video helps if you're struggling with any of these. So usually August is going to be your easiest one. There's definitely be a few questions here and there that are kind of tough, but August tends to be easier. And then January will be your second easiest, I guess, and then June is to be the hardest. So June, January, and then August would be your easiest. All right, so here we go. All right, so remember the multiple choice, technically you don't have to show any work if you were taking the Regents, but I just showed as much work as possible to help you out. And then definitely always make sure you have calculator because a lot of this can be just answered on the calculator. So, all right, here we go. Brian's hockey team is purchasing jerseys. The company charges $250 for a one-time setup fee. So any fee is always going to be your y-intercept, always. So that's your B. $20 for each, so any constant, charge is going to be your slope. So the slope is 23, y-intercept is 250, that is why it is choice 3. All right, number 2, function. Remember, x values do not repeat. That's the easiest way to explain it. Look for the one that does not repeat, and that is choice 4. All right, number 3, which expression is equivalent to this? So basically, I just did distribution on both of these, combine like terms, and get choice 4. Remember that if I'm not showing, the way you did it, doesn't mean your way is not correct. The Regents does technically accept a lot of different ways, especially on multiple choice. We don't see your work anyway, so it could be good. All right, number 4, I did cross multiplying. Make sure that x plus 10 is in parentheses. You know why, because it's a binomial. And you wind up getting x equals 10, and then I just checked it to show you. So that is choice 3. All right, next page, number 5. Josh graphed the function f of x is as follows, and he graphed the function g of x on the same coordinate plane. The vertex of g of x is, okay. So this is your vertex. Remember, you take the opposite of this, so positive 1, positive 2, so positive 1, positive 2. I just did a quick little sketch. And then for g, it's the opposite of this, so 1 and negative 5, so 1, negative 5. So basically from here to here, you went down 7 units, so it's 7 units below. You could also put it in the calculator and graph them and definitely count and see that when you get this graph, it is 7 units down. Okay, number 6, as you can see, you have a two-way table. Make sure with two-way tables, you have to have the totals, okay? You have to have a total before you could solve anything. So it says the nearest percent, what percent of the boys chose Niagara Falls? So there's your of, that helps you kind of, figure out where the denominator is. So of the boys, so total amount of boys, so boys in total is 233 after you add them all up. Niagara Falls, so that's Niagara Falls and boys. So boys, Niagara Falls, 56. So 56 out of 233. Put in the calculator, you should get choice 2. All right, number 7. Which kind of function? You see this curve, it's going to be exponential. Linear would be a straight line. Square root is starting usually at 0, 0, and it's the curve, and absolute value is your v. So square root would be a curve this way, and exponential is usually increasing or decreasing. So this is showing growth. Okay, so that is definitely choice 2. All right, hopefully you guys are doing okay so far. All right, number 8. This is definitely dots, difference of perfect squares. 16 and 81 are perfect squares. You have your subtraction, you have your square roots, or your squared there. So you take the square root of both sides. You're making conjugates, 1 plus 1 minus, and is choice 3. 9, the owner of a landscaping business wants to know how many times on average his workers spend mowing one lawn. So what is the most appropriate rate with which to calculate answer? All right, so he wants to know how much time he spends mowing one lawn. So he basically wants to know how much time, so the hours per lawn. So hours per lawn, that's basically how I got choice 4. All right, number 10. A ball is thrown into the air from the top of the building. The height of the ball above the ground is after thrown can be bottled by this. How many seconds after being thrown? All right, so this one is going to be a quadratic. Okay, I tried to draw it. It's kind of like the person standing on top, and it's coming down. It wants to know at what time over here the ground hit. So I did it 2 different ways. The first one, sorry, it's a little messy. First way is you have to make the h of t equal to 0 because your heights, remember the height, right? Here's your grounds. So this is the height, h of t. This is your ground, which is t. This should be 0, right? This here, right here, as 0, that's going to be your ground. And that says h of t. H of t, let's get rid of that y. Okay, and this is your t. So if I put this equal to 0, and we actually did this on the day that we did our quadratic word problems, we've done something like this. It was a lot of work, but we did something like this. So we added all these terms to the other side because you can't have a negative t squared, and then I took a GCF of 16, and I factored what I had left over, and I got a positive and negative. You know there's no negative time, so the answer is t equals 5. The other way I taught it, and this is the way you guys liked it, was putting it into y equals, putting this equation in there and copying the table. Now, obviously, you don't want to copy any negatives because there's no such thing as negative time, negative height. So you copy this, and this over here, when it gets back to 0, that is where your ground is. And if you notice, it's 5 seconds. So that's choice number 1. So technically, you don't have to show any of this work if you were taking the Regents. All right, number 11, which equation is equivalent? So I noticed that this was in vertex form. Vertex form is always completing the square. So that's what I did. I add 18 to both sides. Then I added b over 2 squared to both sides. And over here, I just factored this to x plus 12 squared equals y. I combine my like terms, subtract the 126, and you get y equals x plus 12 squared minus 162, and that is your vertex, negative 12 and negative 162. So actually, I could have stopped just right here. Didn't even need to figure out the vertex because the fact that those do match, okay? And again, you can do vertex form because you do have a linear term, and this is 1x squared. The other thing is you can put it in the calculator, put this into y equals, and put all 4 of these choices into y equals. And I just copied down a couple points, but just to show you, these do match. Okay, this table and this table will match. So you could have gotten that very easily if you just did it on the y equals instead. All right, number 12, when that is expressed as a polynomial, standard form, remember standard form is ascending power order, means highest exponent to lowest exponent. No, I should write that. Highest to lowest exponent, just so you know that, and then all terms are combined. So I distributed, and then I double distributed, and I got 2x to the third minus 7x squared minus 15x. The constant term, well, there is no constant term, so you assume it's 0. The leading coefficient is 2. Remember, leading coefficient is the first number when the terms are in descending power order, okay? I'm going to put first, I'm going to put the coefficients of first term. So coefficients of first term when the terms are in descending power order. Okay, so hopefully that helps. And this is your first term, so you're good. Degree would be 3. That's the highest exponent. I'll try to write the degree. Highest exponents, and number of terms 1, 2, 3. So the only one that's correct is choice 2. All right, 13. So I said this in the last video that I did, the one for June 2020. The Regents seems to love the exponent rules now. I'm noticing more and more. The more I get more Regents, the more I see that they like the exponent rules. So this is the exponent rule they're using this time. The product to power. So x to the a raised to the b is really x to the a times b. So if you have this, you could multiply those two, okay? That's how you would get your answer. You keep the base, which is x, and you multiply those two. So essentially what they did is they took this on the outside, this 7t, okay? Pretend this is your 7t. And then they just move the 7 to the inside, right? So that's like them moving the a to inside the parentheses, and you get this. So them moving the 7 to the inside, and then produce this. When you put this in your calculator, you get this value, and that's how you get choice 2. So definitely make sure you're good at your exponent rules, because I've been noticing a lot that they've been using them, or asking you questions about them. All right, hopefully you guys are doing okay so far in the first 13. Remember, as we get closer to 24, that's when they are supposed to, get more difficult. All right, 14, the functions f of x and g of x are graphed from the axis below. All right, for which value of x are they not equal to? So basically not equal means does not go through both functions, okay? All right, doesn't satisfy both equations, because that's a fancy way to say it. So for a -1, okay, -1, they do intersect. For +2, they do intersect. For 3, only 1, so that's going to be your no good. -2, they do, so your answer is 3. All right, 15, range. It's always your highest minus your smallest, but we do have a box plot. That's okay. We have our upper extreme or our max, which is 8, lower minus your lower extreme or your minimum, that is 1, so 8 minus 1 is 7. 16, not equivalent. I thought the best way was just basically do guess and check. I just did double distribution for all of them. And this one you had to multiply this one first and then double distribute. And I got 3. It was not correct. That's the one that did not match. And that is a 12. All right, so there probably is another way, but that's the way I thought was easiest. All right, 17. The quadratic function r of x and g of x are given below. Smallest minimum. All right, so this one already gave us a table. They gave us the vertex. Sorry, I can't see that. And then for this one, I put into the calculator, put into y equals, and I got my table. And then I noticed this smallest number was 16, negative 16. This smallest number is negative 9. So that means r of x had the smaller, and the smaller value is negative 16. So that's really all I was asking. 18, a child is playing outside. The graph below shows the child's distance in yards from home, okay? So this is your home, and this is the distance from home, okay? Usually they say it again, but they didn't. So which one shows it moving closer to home? So constant means it's a straight line. It's never going to be a curve. And this closer to home is your distance should be getting smaller. So this would be the section right here. This is constant, and it's showing that the distance is decreasing, meaning you're getting closer to home. So x, or in this case, t equals 0 to t equals 2 is the right answer. All right, 19. I actually really like 19 because we didn't really do something like this throughout the year where they had order of operations, but you guys should hopefully have been able to handle it. All right, so you have a sub 1 is 6, and a sub n equals 3 plus 2 to the... So this is recursive right here, okay? Remember, this n minus 1 makes it recursive, which means if you're trying to figure out a of 2, you're going to be essentially using a of 1. So that's why they give you a of 1. So basically, you write the equation, okay? Wherever you see an n, you put a 2. We do 2 minus 1 is 1. A sub 1 is 6, okay, but notice you have a squared. Usually we haven't really done one with a squared, but that's okay. You do order of operations. So you do exponents first, so 6 squared is 36, then multiply, and then add, you get 75. So I actually like that question. That question was pretty good. All right, last page of our multiple choice. So they haven't been horrible yet, I feel like. Hopefully you agree with me. They have not been too bad. 20, the length of a rectangular patio is 7 feet more than its width W. Okay, we've definitely done stuff like this. The area of a patio, A of W, can be replaced by the function. All right, so W is width, right? That's what they tell us. 7 feet more, it's W plus 7, and you're going to multiply them. You get W squared plus 7W, and the only, I guess, tougher thing they added in was the A of W, but you guys should be okay with that. All right, 21, a dolphin jumps out of the water, then back into the water. His jump could be graphed on a set of axes, where X is time, and Y is the distance above or below sea level. The domain, so the X, remember X represents time, is, okay, so we want to know what's going to represent time. You're going to notice they always ask a question like this every single time or part 1. They're usually asking you about domain and the thing to pick out. So integers includes negative, and time cannot be negative, so that is no good. Number 2, positive. Okay, that's okay because there's no negatives. That's good, but it's not going to include any, doesn't include part of time, not continuous, I wrote. So what about if he's, 2.5 seconds, something like that. So that doesn't include that. So that's going to also be no good. Real numbers, well, that includes negatives, so that's no good. So this will be your answer, positive real numbers. So real numbers include your fractions and decimals and things like that. So partial of a time, 10.5 seconds or 10 and a quarter, something like that. And real numbers means that, that being positive means that it gets rid of the negatives, which is good. So the answer is 4. All right, 22. So this one I thought was a little bit more difficult than what we're used to. You guys are used to multiplying. Oh, sorry, let me start from the beginning. So which system of linear equations has the same solution? So you guys are used to multiplying by the scale factor, seeing which one is correct, not correct. But they definitely made it a little tougher this time because some of these were not. See these top ones right here? They didn't make it in the x plus y form kind of thing. So this one you actually had to solve, but that's okay. Remember, you guys had a 5-question test on this. You guys could totally do this. So I had taught you to bring this down, okay? So actually, I'll make this multiplied by 1 to show you. So I taught you to bring this coefficient up, this coefficient down, and then put a negative in front of it so that you get your additive inverses. So when you combine your like terms, you get negative, that's a 5, y equals negative 15. Divide by negative 5, you get y equals 3. Plug back in, you get x equals 2. So then from there, you just do guess and check. You just try each one. So this one I solved, f of x equals 10. I got x equals 2, which is so far it matches. Plug back in, y equals 3, and that is the winner. I guess you could probably also plug them into the calculator, y equals somehow, and get it. But that's just the way I showed it. All right, 23, which interval represents the range? Remember, range is your y values of the function. So I just want to remind you on this one how to get, okay, so I want to put this in. So 2x squared minus 2x minus 4. When you go to the table, you're going to notice that you don't have, well, first of all, let me show you. So you have your repetition, 8, 8, 0, 0, negative 4, negative 4. You have that symmetry, but you don't have that middle term. Remember, you need that middle vertex. So I wrote the notes here. It's second window, and we usually assume it's 0.5, and I'm going to show you how you could figure that out, but 0.5. And then what that does is between those two negative 4s, it does give you your negative 4.5. Remember, you have to have your vertex. You must always have vertex or a turning point. So I'm going to write that. Must always have the vertex. Okay, so now we have our vertex. So we know this lowest point right here is negative 1.5, negative 4.5. Notice I made it a happy face, and I knew it was a happy face parabola because this is a positive x squared. Okay, so I told you that we always assume that it's 0.5. Okay, but here's how you really do it and make sure it's 0.5. So you have your negative b over 2a, your axis of symmetry equation. You plug in your information, okay? You know that a is 2, b is negative 2, and c is negative 4. And what that gives you, when you get x equals 0.5. So you know that the x coordinate to this vertex is going to be 0.5, and that's how you definitely know that you change your table to 0.5, okay? You could also keep going with this, plug in the 0.5 in for x, and you wind up getting h of 1 is going to be negative 4.5. H of 1. No, h of 0.5. Sorry, this should be 0.5. I don't know why I put. So 0.5, 0.5, 0.5, and 0.5, because that's what you're plugging in. So that should be 0.5, comma, negative 4.5. Okay, so anyway, now that we know what this minimum value is, this turning point, this vertex, and we know that parabola means it goes up, that's going to be it. So it's going to be the lowest of negative 4.5, and it goes up to infinity. So again, this is just the way to get the 4.5 on the table, and this is the way to get your 4.5 by plugging in your 0.5, which is your x. All right, so 24, which again, usually is the toughest question. Again, when you get to 24, it's usually the toughest multiple choice. So this one was, I thought was definitely pretty tough. Okay, what is the common ratio, so your R, of your geometric sequence, whose first term is 5 and third term is 245? So the best thing about this is that it's multiple choice. So basically you just do guess and check. That is the easiest way. So if I start with the number 5, which is my first, a sub 1, this is a sub 2, a sub 3. Okay, so I start with 7. So 5 times 7 got me 35. All right, so now I'm guessing if I take the 35 and multiply it by 7, do I get that third term of 245? Yes. So really, that's the easiest way to do it. But let me just show you if you had to show your work way. So I know 5 times whatever this ratio is going to get me the second term. And I know if I take the second term and multiply it by that same ratio, I should get 245. So I'm going to use this right here and solve for a sub 2. So a sub 2 times r is 245, divide by r, and I get a sub 2 equals 245 over r. So now I'm going to use this formula, or this equation, 5 times r equals a2, and plug a2 for 245 over r. And what that does is lets me multiply 5 times r is 5r squared. 1 times 245 is 245. Divide by 5 gets me r squared equals, that's a 49. Square root of both sides, plus or minus 7. But we know these are not negative, so we're going to stick with the plus. And that's how you get 7 by showing all your work. But again, the other guess and check way, so much easier. All right, so that's all your multiple choice. Hopefully you guys didn't do too bad. Usually on a Regents, you'd want to get 5 or less wrong, because that's going to basically mean you're going to probably do pretty good. So, all right, hopefully you got less wrong on this one than you did on the January 2020. So let's now start on our part 2s. And here we go. So for this one, you want to determine g of negative 2. So basically, just plugging wherever you see a negative 2, you plug in, wherever you see an x, you plug in a negative 2. Just be careful right here. You have to use the parentheses. So important. All right, and then you do order of operations, and you get g of negative 2 equals negative 8. Now, this question did not say algebraically, so the Regents would have accepted the table. Okay, they would have accepted the table as your work to also get negative 8. But I like this way better. That's also a really good way to check it too, by the way. All right, 26. I've been noticing that they've been doing at least one part 2 as number properties, which is very surprising. All right, students in the process of solving an equation, The original equation, the first step are shown below. What property did the student use? Explain. Okay, so this was exactly the same, the left side, so your only difference was the right side. If you notice, these two switched order. Switching order, changing order, change order is always a commutative property of addition. I wrote because the order of the terms -5, a, and 7 is switched from the original to step 1. And then I just showed, the basic property. So just as long as you say commutative property and explaining why, tell me about changing the order, then you got it right. All right, 27. So this one has you graphing a line. So first put it into slope-intercept form. So divide everything by 2. Y equals -3/2 x minus 1. You have your slope of -3/2, your y-intercept of -1. So B for begin at -1. Remember, negative is down, but it's to the right. Down and to the right. So keep going. You make your line. Make sure these are labeled X and Y. One box equals 1 unit. And definitely make sure you're always extending that line throughout the whole entire graph. Don't give me a short little line. That's not good. Don't forget to put the original equation on that line. And I also put that you could put the table. I skipped all the decimals. I just wrote all of the integers down to make it easier. All right, the linear equation contains the points 2, k. State the value of k. So 2, -4 is the one they're looking at. So you could either gotten it from the table. You could have gotten it from looking at your graph, 2, -4. Or you could use the equation from the beginning. Use the equation from the beginning. Plug in x is 2. And then you solve and get y equals 4. And then even did the check for you right there. And even though it's such a little thing, it's really, really important that you have this key. Okay, because it says 2, k, and you're solving for k, but k is really in the y value. So you want to make sure that you have that key, k equals y. It was not too bad. Just like your multiple choice, as we go on in the part 2s, it's going to get more difficult. All right, this is a literal equations. You're always going to get one of these on the Regents. And they use some fancy words, I guess some fancy science stuff you guys probably know. Velocity is v of f. Initial velocity, that's final velocity. Initial velocity is v of 1. Acceleration is a. Time is t. This one we're solving for v of f. So I just showed it 2 different ways. If you did another way, you want me to check it, just make sure you let me know. But I'm sure there's more ways. So here I got rid of the denominator first. Okay. Start with parentheses, very, very important. So multiply both sides by t. T times a is at or ta. This gets rid of that, and it produces the numerator. Add vi, which is your initial velocity, to both sides, and you get the final velocity equals acceleration times time plus the initial velocity. The other way you could do it, since this already was a fraction, put this side as a fraction and cross multiply. This one actually was less work. A times t. That gets that side just like above, add the vi, and you get the same exact answer. So anything like that, just make sure you are showing your work. All right, 29. This was just solving inequality, so hopefully it was not too bad. I moved over the smaller inequality, the smaller x value. Then I added 1/3 to both sides. I got 2/3 is less than 1/5 x. I multiplied by the reciprocal 5. 10/3 is less than x. And then they did accept both ways. They accepted the improper and the mixed. Just be careful when you're swapping these, okay, that it has to, be the same truth value. So x has to be bigger than 10/3. X has to be bigger than 10/3. So I just said be careful. And then I just showed it the same exact way, just moving the constants first. But either way, you get that 10/3 or 3 1/3. So that wasn't too bad. So hopefully you could tell that this August one wasn't as bad as the January. Again, August is usually when it's going to be a little bit easier than the rest of them. All right, number 30 is the product. So product, you have to know means multiply. Of 2 irrational numbers, always irrational, justify. So I thought this was a little more difficult. Usually they give you the numbers and then ask you if it's rational or irrational. So this for an August I thought was pretty tough. So this is the one where you kind of have to know the rule, or you have to just keep trying out examples and see if it's right or not. So the rule is the product of 2 irrational numbers is sometimes irrational. And I gave you a sheet that had all these rules on it. So that's where you would find this. It is possible that the product of 2 irrational numbers will be irrational. So because of this rule, the answer is no. The product of 2 irrationals is not always irrational because it's sometimes irrational. And I showed 2 examples. I showed you one where it does become, where the answer is irrational, and one where it's rational. So these are irrational, -5 and 2. When you multiply 5 times 2, you get 10. Radical 10 is still irrational. But here's 2 other irrationals, 8 and 2. By the way, irrational means, non-terminating, non-repeating, can't be written as a fraction, things like that. So radical 8 times 2, so 8 times 2 is 16. But look, that's a perfect square. So that is going to give me rational. So sometimes it is, sometimes it's not. So that's why this answer is no, because they're asking for always. So that would be a no. All right, 31. So 6x squared minus 4 equals 0. So exact values, that means no rounding, okay? This is interesting. Usually they don't say this. Usually they have you round. So this is how they, you know, the Regents likes to switch things up a little bit and throw things in there you're not used to seeing. So I did this a whole bunch of different ways, all right? So algebraically, add 42, divide by 6, square root plus or minus radical 7. Factoring, don't forget it's equal to 0. So I took a GCF of 6 out first, which is not equal to 0. And then x squared minus 7. You basically now have to do algebra, so add 7, square root, same answer. Completing the square cannot be done. There's no b term, there's no linear term, so that's no good. And then here's the work if you did the quadratic formula. The only tough part here was this 1008. Remember, in order to get those factors, you're just going to go to y equals. You put 1008 divided by x, second graph, and you look for anything next to one another that is, oh, let me change this back, my window. Second window, 1, anything next to each other that are your whole numbers or your integers, and 7 and 144, remember, because 1 has to be perfect square, is it? So I showed you 3 different ways. Whichever way you would have done it, you should have gotten plus or minus radical 7. Okay, getting there. All right, 32. Piecewise. So they like to do piecewise now, which is not too bad. All right, so the first one is linear. So you could use your M and your B or your table, whatever you're more comfortable with. So remember, you begin at -3, and you go up to right one, up to right one, up to right one. Okay, and you could imagine this line right here. But now I have to go to my constraint. Remember, this is called a constraint. So I go to the dot where x is 0. That would be this dot right here. It's an open, so I erase it and I put an open circle. And I want the x values that are less than 0. That would be this side right here. Okay, that's the side you're keeping. Don't forget about the equation and the constraint. You could also put the table if that's good for you. Okay, the second one is going to be a quadratic, a parabola, and I'm only going from 0 to 5, and parabolas can only be done using the table. So from 0 to 5, you see what I got right here. And basically, both of these are closed, okay, because you have the less than or equal to underneath. So this is what it looks like. Don't forget your equation and your constraint. Your 1 box equals 1 unit. This is a function because you have 1 open and 1 closed. So I wrote that. It's also discontinuous because you have to pick up your pencil. Yeah, that's really about it. The only other thing I want to remind you is how to do this in the calculator. Okay, when you do, and I'll just put the first one. I won't do the whole entire thing. You have to make sure that the, 2x minus 3. You have to make sure that the function part, the equation part, is in a parentheses separate from the constraints. And I also put second math, less than 0. Okay, actually, I might as well do the whole entire thing. Why not? So x squared minus 4x minus 5. Remember, this is a compound, so you have to do them separately. You have to do 0. Then your second math to get your symbol, less than or equal to x. And then our separate one is going to be now, so remember, this is 1. It's kind of hard to see. And then like this is 1. X is less than or equal to 5. And you graph it. We should get a little line and a little piece of parabola. And look. There you go. So don't forget, you can always check it. All right, 33. The Regents love systems of inequalities. They always ask system of inequalities, always. Okay, or just really one inequalities. I guess I kind of ask them both, but you definitely have inequality. So here you subtract 2x. You have your slope and your y-intercept. This symbol means it's solid and shading above. So begin at 8. You're going to go, 8. You're going to go down to right 1, down to right 1. Okay, you have that solid line. Here's your y-intercept. You want all values that are greater than 8. So that would be 9 and 10 here. So that's how you know to shade in this direction. And be careful that inequality must be in the shaded region, not on that line, and it has to be the original. All right, next one, add 5 to both sides. You have your slope and your y-intercept. Start at 5. We're going to go, this is positive, right? Yep. So up 3, right 1, or down 3, left 1, down 3, left 1. This symbol means it's dotted. So that's how it's dotted. Make sure you know it's dotted. Tell the person grading it that it's dotted. And it's going to be shading below. Make sure this is the original, okay? And then this question, they love to ask this question. They're always going to give you the dot. That's one is dot, the point where it's either, you know, on, look here, it's on the dotted and it's inside the shaded. So they're always going to ask you a question like that. So I put no, 1/8 is not a solution point because it's on the dotted line, right? Here's a dotted line. Dotted means not equal to. So therefore, any point on that line is not a solution point because it doesn't satisfy both inequalities. So you basically want to make sure that you know that whole entire thing, okay? And then I put it into each inequality just to show you that one works and one doesn't, so it doesn't satisfy it. All right, question 34. So on the day Alexander was born, his father invested $5,000, that's your principal, in an account with 1.2% annual growth rate. So percentage is going to be your rate. Growth is going to mean it's increasing, so it's going to be plus. Write a function a of t, so you have to have this a of t over here. It's wrong. That represents the value of his investment t years after Alexander's birth. So instead of n, you'll use t. So you want to use this formula right here. So basically, again, this is your P. So A equals P, 1 plus or minus R. R is going to be your rate, and N is going to be your T. So this would have to have been memorized. They wouldn't give this to you on the region. So, okay, so 5,000 for the P, 1 plus 1.2% to the T. I guess we can write for a key N equals T since we're switching things up a little bit. That might be important to have. All right, so 1.2%, once twice to the left is going to make it a decimal, 0.012. Make sure it's plus for growth. Add those together, get 1.012 to the t. Again, make sure you have that a sub t there in the beginning, super important. All right, next part, turn to the next dial. That means nearest whole number. How much more? That's subtraction. The investment will be worth when Alexander turns 32, when he turns 17. So you basically want to use the formula that you came up with over here. And here you want t to be 32, and here you want t to be 17. So I plugged them in, and I got the decimals. I didn't round because you really should be rounding at the end. And then this is what I got. And the nearest whole number, this would round this up to 1,200, okay? Now, I noticed that it did not say algebraically, so you really could have done this on the calculator, okay? You just go into y equals, you plug your formula in. I kind of already did it for us. And then you go down to 32. It says 7,324, and then if you went back to 17, you would have saw it was that 6,124 number, so it kind of rounds it. When you subtract those, you still get the 1,200. So that definitely would have been acceptable. They also allowed you to show this little bit of work on the regions, but again, because it doesn't say algebraically, you could use the table to get your values, or you can plug in your values here. Again, T for 32, T for 17. Get those values, subtract them, but however you do it, you're going to get that it's $1,200 more. All right, 35. They're always going to ask a question like this. Okay, Stephen collected data from a travel website. The data included hotels' distance from Times Square in Manhattan, I love Manhattan, and the cost of room for 1 weekend in August. All right, so we have this linear regression. Remember, this is your line of best fits. Okay, it just wants the equation. So what you're going to do is you're going to press, let me get out of here, stat 1, okay, and you're going to put all these numbers in. So 0, 0, 1, 1, 3, 4, 7, 11, 14, and 19. And then let's do our other numbers. 293, 263, 244, 224, 185, 170, 219, 153, 136, and 111. And then we're going to go stat calc. Remember, there's your linear regression number 4. I'm going to go down to calculate, and it'll give me my equation. So negative 7.76 is one's nearest hundredth, and 246.34. So that wasn't bad. Now the bottom part's the correlation coefficient. Let me just remind you, if you don't have the R on, the easiest way is the mode way. So mode, you're going to go down to the next screen, and you want to have that stat diagnostics on. Okay, this is the easiest way. If not, you go to the catalog, which is second 0, and you scroll down until you go to D, diagnostic on. Eventually we will get there, diagnostic on, and it turns it on. So that is how you get the R. So the R was negative 0.88. So it's a negative. So that means as one value increases, so your distance from Times Square, one's going to decrease your cost of the room. Okay, so this is interesting. It didn't even ask you to explain what this means. It asked what the sign meant, which I thought was very interesting. And again, you see that context. Okay, the Regents is all about words. So it's all about the context, okay? So I wrote that you must use the words from the problem. Don't make up your own words. Use these words. Okay, so we're going to basically explain this right here. So the negative sign suggests a negative correlation, okay? So this is what negative correlation looks like. And you tell me as x increases, y decreases. So x was distance from Times Square, okay? X was distance from Times Square. So as the distance from Times Square increases, now tell me the y decrease. What was the y? Cost of room. The cost of a room decreases. So you'd have to have this information to get full credit. Okay, you can also tell me this. Correlation coefficient shows strong negative linear relationship because correlation is close to +1, but make sure that you are telling me all the words, right? Context, words from the question. And this makes sense. You know, Times Square is really expensive. Any hotel is really expensive, but as the further you get away from it, that's, you know, fancy Times Square, the prices will go down. So this is real life. So this is a good question. You guys can actually understand that. I can also say that the cost of a hotel room goes down the further away from time. Oh, so I guess it's just another way that was accepted on the Regents. But just make sure you have your equations, your correlation coefficient, and then you must use the words. And again, use their words that they give you. Don't make up your own. All right, last two. And again, these should be your toughest ones. As we get closer and closer to 37, these are going to be really tough. All right, so I didn't think 36 was too tough. I just think that we've never really done something like this before. So I don't know. To me, this was like more like a science lab question. I don't know. Maybe I'm wrong, but all right, let's see. A snowstorm started at midnight. For the first 4 hours, it snowed at an average rate of 1/2 inch per hour. So I wrote from hour 0 to hour 4, it went 1/2 inch per hour. Okay, and then when you got to the end of hour 4, you're at 2 inches. The snow then started to fall at an average rate of 1 inch per hour. So now it's snowing more for the next 6 hours. Okay, so this is hour 4 to hour 10, so 6 hours in total. And now it went to 1 inch per hour. So the ends of the hours, the 10, you should be up to 8 inches. Okay, here it snowed total 6 inches. This is going to have 8 inches. I'm going to write total here so we know that what we're talking about. Then it stopped snowing for 3 hours. So that means whatever you have on the ground, that's what it's going to be. Okay, so it's going to stay at that value from hour 10 to hour 13. Remember, hour 13 is really 1 p.m. It's going to stay constant. So you're at that 8 inches total still, okay? And then it started snowing again at an average rate of 1/2 inch per hour for the next 4 hours. So 4 more hours, 13 to 17. This is 5 p.m., 1/2 inch per hour. So it snowed 2 inches in 2 inches. So now you're at 10 inches in total. All right, so they wanted you to graph it, and thank goodness it's already set up for us. Elapsed time, accumulated snow, that was really good. Just add your title in. All right, so here we go. So from hour 0 to hour 4, it went 1/2 inch per hour. So hour 1 should go 1/2 inch. Hour 2, another 1/2 inch. So basically one box, right? Because each box is half. Hour 3, another one, and hour 4. Like I said up here, the total at the end should have been 2 inches, and that's what you have right here, 2 inches. All right, so now from 4 to 10, so the next 6 hours, it's going to go 1 inch per hour. So now you're going to move 2 boxes. So for the next hour, it's going to go up to 3 inches, then 4, 5, 6, 7, 8. All right, so at the ends, you should be at 8 inches. Now here are the 3 hours, 1, 2, 3, that represent the no snow. So it's staying constant, okay? And then the last 4 hours, half, 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 and it gets you up to that 10 inch after your 17 hours. So all of this is that little graph. All right, and then they snuck in an average rate of change over here, which I thought was interesting. Snowfall over the length of the storm. So that's x equals 0. So like the beginning, start to finish. So beginning to 17. Okay, so x1, right? So this is going to be x1. This is going to be x2. So f of x2 minus f, remember, this is what the formula you have to use if it's average rate of change. So f of 17 minus f of 0. Okay, so when x is 17, what was your y value? How much snow was there? 10. Okay, when x was 0, how much snow was there? 0. So that's going to be 10 minus 0, 17 minus 0. That's 10 divided by 17, which is 0.59, and that's nearest hundredth. Okay, I just showed another way, 10 divided by 17. That really, to me, is not average rate of change, but I think the Regents accepted it. But nearest hundredth, 0.59. All right, number 37, your toughest one. So like I stated in the January Regents video, this one is usually going to be a systems. It's either a graphing systems or an algebraic systems. Sometimes I've seen it be a parabola graph, but usually lately it's been like this. So this wasn't horrible. I mean, the last part I thought was the toughest, but it makes sense. This is your toughest one. So here we go. Alyssa spent $35 to purchase 12 chickens. She bought 2 different types of chickens. Americana chickens cost $3.75 each, and Delaware chickens cost $2.50 each. Okay, so system of equations. This is your money plus money equals money, and then number plus number equals total number. Okay, so they already told us the legend, so we are not making up anything else, but we have to use A and D. And if you want to switch up the letters, you have to use a key, but kind of use the same exact thing that they give you. It's probably easier. So A plus D. So your American chickens, your Delaware chickens is 12. And it's $3.75 for the Americana. And where am I? $2.50 for the other type. So that's your systems. Okay, this says, now see how this says algebraically? So there is no table allowed. You cannot go to your table to get any kind of question. So you want to do this. I showed it elimination here. I also showed it substitution above. I'll show you that. Let me do an elimination first. So this has a coefficient of 3.75. Bring that up. This is a coefficient of 1. Bring that down and make sure it's negative. So when you are distributing, you get your additive inverses. That will cross those out. You get 1.25. D equals 10. Divide by 1.25 and you get D equals 8. So Delaware chickens, there are 8 of them. Plug back in. Don't forget to write the original first. And you get 4 for your chickens. Now if you want to do substitution, you could have solved for A. Or you could really, I guess, could have solved for D as well. I didn't show that. I just went for A because I like the letter A. So you take this, plug it in for here, you're going to distribute, and then combine your like terms, solve, and you will still get the same exact answer. So they'll accept anything that is done algebraically. Okay, so now we're going to go to this last part. This is the part that I thought was the pretty tough part of this 37. It's where the conversions come into play. Usually you have the conversion of the multiple choice, but this time they put it in part 2. So here we go. Each Americana chicken lays 2 eggs per day, and each Delaware chicken lays 1 egg per day. Alyssa only sells eggs by the full dozen. So dozen, you have to know that means 12 eggs. Determine how much money she expects to take in at the end of the first week. Careful. They made it tricky. There's your conversion, weeks to days, okay, with her 12 chickens. All right, so I showed it 2 different ways, a little messy, sorry. So the easier way, I guess, so she had 4 Americana chickens. Those laid 2 eggs each per day. So 4 times 2 is 8. Then she had 8 Delaware chickens, okay, and they laid 1 egg per day. So 8 times 1 is 8. So in total, her chickens laid 16 eggs per day. So then I converted to weeks, right? Because it says not per day, we want to know for a week. So I times it by 7 and got 112. Remember, you could do it this other way, the fraction way. Let me zoom a little bit because that's the other way that I had taught you how to do the conversions. So it would be 16 eggs over 1 day times 7 days over 1 week. And then those days would cross out, leaving you 16 eggs per week. Actually, that should be 112. 112 eggs per week. Okay, so then what you want to do now is you want to change the individual 112 eggs. You now want to change it to dozen. Okay, so the simplest way is just take the 112 and divide it by 12, okay, and that's going to give you 9 1/3 dozen. The other way, the conversion way that we've done it with the fractions, is you do 112 eggs and you multiply it by 1 dozen over 12 eggs, right? Because 12 eggs in a dozen, that means those eggs cross out, leaving you with 112 times 1 is 112. This is essentially 1 times 12 is 12. 112 divided by 12 is 9 1/3. So either way, you're going to get that 9 1/3, whether you do it, the basic way or this fraction way. Okay, so now you have 9 1/3 dozen. Remember, you want full dozen, so you're not going to use that 1/3. You're just going to use the 9. So $2.50 times 9 is your full dozen, and then it gives you 22.5. So she will make $22.50 at the end of the first week. And the only other thing I showed over here was just a different way to do the 112. But again, you can go from the 16 eggs per day, multiply it by 7 to get the 112 eggs per week, again, or do this fraction conversion over here to get 112. And then once you have the individual amounts, the total individual amounts, you want to turn that to full dozen, so divide by 12, or again, do this fractional part over here, fractional conversion to get 9 1/3. Again, we're ignoring the 1/3 because we want full dozen, so that's 9. 250 times 9 is 22.5. So again, this is what I thought was the toughest part. So all right, so hopefully you did okay on this Regent. So make sure you post all these pages for me on Google Classroom so you get the credit for it. If you have any questions at all, please reach out to me. If not, hopefully it went okay for you. So, all right, have a great day. Take care.